Dear students, I explain in this video how can we calculate the omega GC and omega PC in polar plots. So for calculating of omega GC and omega PC in polar plot, so initially we can draw the unit circle radius. So unit radius circle. So that is one unit radius circle initially we can draw. After drawn that unit circle, we can draw the polar plot. The polar plot reached or the polar plot touching the negative real axis, that is minus 180 degrees line. This corresponding frequency is nothing but omega PC, phase crossover frequency, and the polar plot touching to the unit circle line, this point is nothing but omega GC. So this is the procedure for calculating omega GC and omega PC in polar plot. So initially we can draw the unit radius circle and draw the polar plot. The polar plot touching to the negative real axis, that is minus 180 degrees line, the corresponding frequency is nothing but omega PC. The polar plot touching to the unit radius circle, the corresponding frequency is nothing but omega GC. So this is the calculation of omega PC and omega GC. In this case, omega PC is greater than omega GC. This is omega PC and this is omega GC. So omega value starting here, omega is equal to 0. This is the starting point. So increasing like that, and omega is equal to infinity here. So that this value is less than compared to the this frequency. So omega PC, this is omega PC is greater than omega GC. So this is omega GC is less, omega PC is more. So this is the increasing order for the frequency. Why? Because omega is equal to 0 starting point and omega is equal to infinity ending frequency. So next one, omega PC is less than omega GC example. Again unit radius circle and polar plot. The polar plot touching to the unit radius circle is nothing but omega GC. The polar plot touching minus negative real axis, minus 180 degrees line, this point is nothing but omega PC. Here omega is equal to 0, this is the starting point, and omega is equal to infinity, this is the ending point. So starting frequency here and increasing the frequency, this is less frequency than compared to the this one. So that omega PC is less than omega GC example. So this point at omega is equal to minus 180 degrees is nothing but a point minus 1 plus j0 on the negative real axis is called as critical point in polar plot and Nyquist plot analysis. So that the negative real axis unit distance point is nothing but, so this is the point, this is the point on negative real axis, one unit distance point is nothing but critical point. Based on this critical point we can calculate so system omega GC and gain margin and phase margins. So determination of gain and phase margins in polar plot. So this is the formula for gain margin. Gain margin is equal to 1 by, so mod omega, mod g of j omega and h of j omega at omega is equal to omega PC. So simply it can be written as gm is equal to 1 by, so L of length of 0 q. So this is the 0 point and this is the q point. So this is one is the q point, 0 point and q point. So the length of these 2 points is nothing but, so gm gain margin. So on phase margin 180 degrees plus at an angle of g of j omega into h of j omega at omega is equal to omega gc. So here we can calculate the angle of g of j omega into h of j omega. So this is the calculation of angle of g of j omega and h of j omega. The angle between, so 0 degrees line to the, that is omega GC line. So this is the omega GC. So the polar plot touching to the unit radius circle is nothing but omega GC. So we can draw the line from origin to this point. The angle between 0 degrees line and this line is nothing but angle of g of j omega into h of j omega. So 180 degrees plus this angle is nothing but, so phase margin Pm. So like this we can calculate the gain margin and phase margins. So this is gain omega GC is greater than omega PC example. So same as polar plot. So same as Bode plot, polar plots also in polar plot also we can define the system either stable or unstable or marginally stable. Here also same the condition. Omega GC is less than omega PC. GM and PM are positives, then the system is stable. Omega GC is greater than omega PC. GM and PM are negative. System is unstable. Omega GC is equal to omega PC. GM and PM is equal to 0. So the system is marginally stable. These three statements are same as it is in Bode plot. Now consider the one more example on polar plot. So g of s is equal to 1 by s square into 1 plus s into 1 plus 2s. Sketch the polar plot and determine the gain margin and phase margins. So initially we can place s is equal to j omega and calculate magnitude and phase angle, magnitude and phase formulas, and also identify the corner frequencies. So omega c1 and omega c2. So what is the necessity of these corner frequencies? So based on this corner frequency, we can select from where which frequency to which frequency we can draw the polar plot. So that means these corner frequencies are must and should include in polar plot. That's why we can calculate the omega c1 and omega c2. If you not calculate the omega c1 and omega c2, so we want to take the omega values from 0 to 100 like that. So no need to calculate the 0 to 100 frequency. So this indicates so where we have to put the more concentration on frequencies. These corner frequencies must and should include in the frequency points. That's why we want to calculate the initially corner frequencies omega c1 and omega c2. So now magnitude formula and phase formula. So this is the phase and corresponding phase magnitude table. So here the frequencies are 0.45, 0.5 and so on 1.0. So here two corner frequencies are included in this table. That's why so initially generally we are taking omega is equal to 1, omega is equal to 10, omega is equal to 100 like that. So for this type of problems, no need to calculate omega is equal to 0, omega is equal to 100,000 like that. So simply we can calculate the corner frequencies omega c1 and omega c2. Then based on this corner frequency we can select the frequencies. These two corner frequencies are included in this table. So this is the magnitude and phase angles. The corresponding polar plot is like this. So based on so initially we can locate the different points based on the different frequencies, based on the different angles for the different frequencies. Finally we can combine all these points, we can get the polar plot. So now we want to calculate so pm and gm for this polar plot. So draw the unit radius circle. So this is the unit radius circle. This unit radius circle touching to the negative real axis is nothing but omega GC, omega PC, phase crossover frequency. But here the phase margin is not touching to the minus 180 degrees line, so that there is no omega PC. Omega PC is not there. So phase crossover frequency is not there. Only omega GC is there. So here, so the magnitude, this polar plot touching to the unit radius circle here. So this point is nothing but omega GC, gain crossover frequency. Therefore, the gain margin Kg is equal to, so mod G of J omega that is equal to 1 by infinity that is equal to 0. That is, so the, the formula is 1 by mod G of J omega at omega PC. So that omega PC, the magnitude value is infinity. So that so 1 by mod g of j omega that is equal to 1 by infinity equal to 0. Phase margin gamma is equal to 180 degrees plus 5 gc that is equal to 180 degrees. So minus 270 degrees that is equal to minus 90 degrees. So from here to here the frequency is nothing but, so from here to here 180 degrees and from to here that is nothing but 270 degrees. So this is the line. So the angle from 0 degrees to this line is nothing but 270 degrees. So that 180 degrees angle of g of j omega into h of j omega. the angle of g of j omega and h of j omega is nothing but the angle between this 0 degrees line and this phase margin. So this polar plot line. So that from here to here, the total angle is 270 degrees. This is in so clockwise direction, so that minus 270 degrees. Therefore, phase margin gamma is equal to 180 degrees plus 5gc formula, that is equal to 180 degrees minus 270, that is equal to minus 90 degrees. Therefore, gain margin kg is equal to 0 and phase margin gamma is equal to minus 90 degrees. So this is the calculation of or the drawn the polar plots for different problems.